Okay, so in this data set, we plotted some frequency diagrams, some frequency plots, given summarized data of interval data. Actually, yes, of interval data, where we were told what the answers could be, size 4 through 12, or unknown, and we were given the summarized data of how many people said what. So this is already somewhat summarized data. Let's look at the distance to school tab. Here, we were asked people, how far do you travel to get to school? An open-ended question where they can give you any answer they want. 0 would be meaningful as well, so this is truly ratio data. Somebody could say, I didn't travel at all, I live at school, in which case their distance to school would be 0. So we have here ratio data coming from the response to an open-ended question. How far do you travel to school? You'll see this data on page 25 of your text. If you turn to page 27, you'll see a plot of the distance traveled to school. We'd like to create this plot so we can visually represent how often people travel what distance to school. In order to create this plot, we must create a histogram. We must create a histogram. Well, the first thing we need to know to create a histogram is what is the range of data that we have. Let's go ahead and first find out what the range of distances people had to travel. So there's a minimum distance and a maximum distance people traveled. Well, you can visually search through this data to find the minimum and maximum. Excel will also find it for you by using the formula min, M-I-N, then choosing the array of numbers you want to analyze. And there we have the minimum of 0.5, and let's also find the max using the Excel formula MAX for maximum, the largest value within the data set. And we see we have people traveling somewhere between a half a mile and 34.1 miles. So if you had to make a list of distances that people travel, well, they can travel up to our distance up to a mile, 2 mile, 3 mile, 4 mile. I can just keep typing in, or I can say 1 plus the one above it. Take the one above and add 1. That's 1, 2, 3, 4, and just keep copying and pasting until I get down to about 35 miles. Let's see if I have 35. I have 36. There's 35. So now I have the different ranges or intervals of data that we can take a look at for people to actually travel. To plot this data, we're going to have to add a histogram. Now, a histogram is going to require an advanced tool on Excel. I already have it loaded. It's called data analysis. Some of you may not have it loaded, so let me show you how to load it. Going back here, so here's your home, hit File, Options, Add-ins, because the data analysis tool is an add-in. When it gets to this tab, Manage Excel Add-ins, hit Go. And you see Data Analysis Toolpack is selected. If I can deselect it, now you will find on the Data tab, it's gone. And I can also select it, Options, Add-ins, Excel Add-ins, Data Analysis Toolpack, OK. And there it is, my Data Analysis Toolpack. In your Data Analysis Toolpack, I just clicked on it, you see a lot of different data analysis tools. ANOVA, correlation, covariance, descriptive stats, smoothing, F-test, Fourier, histogram. Histogram is what we need today. But let's just keep looking at the menu. Moving average, random number generator, rank and percent. That sounds like ordinal data right there. Regression, sampling, t-test, z-test. Lots of different tools. Over the course of this workbook, we'll actually be using almost every single tool within the data analysis toolpack. And definitely by the time you finish this workbook, you'd have enough knowledge to say when you might want to use one of the other tools that we do not cover in this tool pack. So I say we need a histogram. So I'm going to select histogram, say OK. What a histogram does is it creates a frequency, counts a frequency at which data appears within some interval. So the input range is the data I wish to analyze. So I wish to analyze the distance traveled. There we have it. Notice there's a blank cell. Excel will ignore that, so that's fine. Our bin range is the upper limits of my intervals. I want to say that again because you have to remember this. The bin range is the upper limit on my intervals. So I'm going to hit that little selection bar. And notice here's the up to. So this is the 0 to 1 distance traveled, all the way down to 35 miles being traveled. Output range. I can let it go to a new worksheet apply, but since I'm working with this worksheet, I'd like to keep the output on this worksheet. So I'm going to select output range and say put it here. When I say put it here, it's going to put the output over there and down. So we're good with this. Okay? Okay. Notice it repeats the bins, which is exactly equal to my upper limits. In fact, I'm going to relabel this to upper limit. And also wrap the text to make it look pretty. Home, wrap text. And there's the frequency. 3 people traveled less than a mile. 1 person traveled between less than 2 miles, but more than 1 mile. 2 people traveled less than 3 miles or less, but more than 2 miles. 9 people traveled 4 miles or less, but more than 3 miles. It is a frequency count of data within this range. We'll now create a plot. So I'm going to go ahead and use the standard approach for creating a plot. Insert a column plot 2D. There it is. We need to select the data. Add distance traveled is a great name for it. Series values is the frequency, just as we've done before. Do not include the more. If you want to know how I'm going around so fast, it is literally the arrow keys. You can hit them one at a time. If you hit Control, you go all the way down quickly. If you hit Shift, you select more than one at a time. So Shift, Control, and down arrow will quickly get you all the way down to the end of the data, which then you can back up one and just select the data you're plotting. Okay, and now let's get our axis labels. That's my upper limits. There we go. Okay, okay, take a look at our plot. There's only one series being plotted, so there's no need for a legend. We need to, of course, title things, so I'm just going to go over here to layout. Always title your axis. Always title your axis. That way anybody can look at your data, look at your plot later on, and know what it is you are plotting. Travel in miles. Distance traveled in miles. When you put a parentheses in miles, it communicates as well that what your unit of measurement was miles, not kilometers, not feet, not hectares, which is a unit of area, by the way. Let's go ahead and change the title to be something along the lines of the question asked. How far do you travel to school? Question mark. And finally, again, we have the continuous data, so we need to remove those gaps. Format data, series, gap list, go back and add the border so that everything is clear. There we go. So that's our frequency plot of the distance traveled to school. Quick and easy to take a look at and see how far people travel. Since we might want to compare across data sets, instead of using the absolute frequency, we may want to use percentage. And our percentage would be the number of people in the group divided by the number of people in all the groups. So now we have all the answers, or all the responses. Putting this the dollar signs into the sum portion because I want to keep the row number constants as I copy from row to row of the total sum of responses. Finally, changing it to percentage, copy, and paste. There we have it. And I can also just move this over one. There we go. Going to scroll out a little bit. So here's our raw data. I found the range of data. In fact, I can say what is my range here. And my range is somewhere between, I have to travel up to 35 miles, and I span a distance of 33.6 because I have a whole half a mile to begin with. And there's my plotted data, my frequency plot. And there's my plotted data, my frequency plot. Excellent. Let's take a look at this plot, though, and think about trying to analyze it or understand it more deeply. I can do some cool things. I mean, like I don't have the 2. I can actually select this, just make it a little smaller until suddenly the numbers appear. There it is. Control Z. But I'm okay with this. Something I might want to do more accurately is format the axis and change the interval. Yes. Specify interval up to 5. And there we have it going by 5s. Here's what I have a problem with this plot, though. It communicates people travel, that about 30% of the people travel 4 miles, but 0% of the people travel 21 miles. In fact, no one travels anywhere between 12 and 35 miles. They only travel here. Now that, of course, sounds ridiculous. It's communicating that no one travels in this distance up there as well. Format data series, close. I need to be able to see this a little bit better, so I'm not going to specify. I'm going to leave this automatic close. It says nobody travels between 31 and 34 miles. They only travel at the 34 to 35 range or at the 28 to 29 range. That's a little bit ridiculous. And this is why sometimes using unit intervals just doesn't make sense, beyond the reason, as we explored in female shoe size. In some cases, we want to group the data together into higher size intervals. How many groups? It's up to you. You can use intervals of 5. That would make sense. You could use intervals of 10. You can do that as well. One way that I like to think about it is, here's my range of data. I have 33. How many intervals do I want? I'm going to make column F a little wider. Intervals desired. And I like to use 5 or 7, sometimes more. Either 5 or 7 is typically what I'll use, unless I have a logical reason to use something else, like go by 5,000s or go by 10 or something of that nature. So I'm going to use 7 intervals. Now, what is my minimum interval size? If I need 7 intervals to cover a range of 33.6, well, my minimum interval size, each interval must be at least the range divided by the number of intervals large, or must be at least 4.8 units large. Great. That part is analytical. Now comes a little bit of art. You get to choose chosen interval size. And the issue here is that 4.8 says the exact size of my minimum interval for me to use 7 intervals and cover this range of data. And I would start it at exactly 0.5. It doesn't really make sense to start at exactly 0.5, and it most certainly doesn't make sense to use intervals of 4.8. I mean, who counts by 4.8? 0, 4.8, 9.6. I mean, it's just, nobody counts by 4.8. We count by round numbers like 5s, 2s, and 10s. So if this is my minimum, I need to choose something bigger than my minimum. And what's an easy round number bigger than 4.8? Well, that's pretty obvious. It's 5. So I'm going to go by intervals of 5. Going to move this off to the side and start now creating a plot with intervals of size 5. There I need a lower limit and an upper limit. I'm going to go ahead and wrap the text so it's easy to read. So my lower limit, I had a misspelling there. It's going to start at 0. The next interval up has to be equal to 5 greater than the one I had before it. And I can hold that 5 constant as I go from row to row. So there we have it, holding that constant. What's my upper limit, though, of my first interval? I've clarified the importance of being non-overlapping. So to make this non-overlapping, I cannot use 5. I have to use something less than 5, like 4.9. I can just type in 4.9. I like to be a little bit more fancy than that and ask, how did I get that 4.9? Well, I subtracted a tenth from this one. So I'm going to make this equal to that minus a tenth. I could have subtracted a smaller portion. I think a tenth will do fine. Copy and paste. And yes, I do have a negative 0.1. That's because it's subtracting from nothing. This implies I'm going to need to go one extra interval. But in any case, I'll show you what I mean. Okay, here I now have a lower limit going from 0 to 30, an upper limit going from 4.9 to 34.9. This last row doesn't matter, so I'm going to delete that. I'm going to leave this because I use that 35 in this formula. And from 0 to 34.9 does cover my range here. So this is a great set of intervals for me to use in my plotting. Next, I'm going to go back to the data analysis and do another histogram of the data, keeping with the exact same data being used for the input, but this time my bin range is my upper limits of these just 7 intervals there. Controlling the output, I'm going to choose a new place to put the output. I am going to skip one column because I'm going to use column P later on and put my output right there. Say OK, say OK. And you see here the bins being listed are the upper limits of my intervals. My intervals are from 0 to 4.9, 5 to 5.9, 10 to 14.9. And there's my upper limits being listed as my bins. There's my response frequency. I can just as easily calculate that the probability percentage equals 18 divided by the sum of all of the responses. There we have it. So I have about 58% people saying that they travel less than 5 miles. Very, very concentrated answer. Putting the dollar signs so I can hold the denominator constant. Copy and pasting. And I have about 13% saying they travel somewhere between 5 and 10 miles, or 9.9 miles. Finally, let's plot this. There's my plot. I'm going to copy and paste it. Oops, I don't know what I just did. Copy, paste, there we go. Now I'm just going to go ahead and go to the select data format. Here we have it. Select data. Edit, and the data I wish to select is this percentage. Okay, and edit these categories, and that's where I have a problem. I need some access data labels, and I don't really have them. I'm going to go ahead and put those there in the future. So for now, I'll just select a blank space, and then I'll create them. Okay, the labels. Now you see why I chose to leave the labels blank. I need to have labels that go from 0 to 4.9. I can type it in using that apostrophe 0-4.9. That would definitely work. However, I don't want to type it every time. So I'm going to use another function in Excel of adding text. And you add text with the ampersand sign. And I'll show you that. equals, I need that 0 and percent, shift 7, open parenthesis, space, dash, space, close quotation, open quote, close quote, another ampersand sign, and now I'll choose the upper limit. You see the formula? Now watch what it does. It creates a beautiful label. I can now just copy and paste this straight on down. Using the formulas makes it much easier to use Excel. Let's take a look at this formula because I think you'll be using it several times over the course of over the course of this instruction. Here's my first cell. Anding says and the next part of the text. And is like addition of text. So it's like plus, but for text. So here's my first piece of text, and here's my next piece of text, the space dash space, and my last piece of text, the cell 08. Makes some beautiful little labels, which all appear down here. I'm going to move this plot over as well, so you can see both the plots at once. And let's compare the plots. With the unit intervals, it would imply that nobody traveled this distance, which of course is illogical. By using grouped intervals, intervals of size 5, there, we were able to say most people travel less than 5 miles. Some people travel larger distances. It's a very clean and simple little plot that says how far do people travel. If you compare that to your book, you'd see that you have made the plots on page 30 and on page 27.